I can replace any row with a multiple of itself. In other words, you guys, what I'm really suggesting is this. I can rewrite this augmented matrix as a 4, 6, 22, 3, negative 4, negative 9. Somebody help me. Why is this legal? Why is that legal? What about the constant? Go back to the equations. What about it?
Constant times a matrix is the same as each component times a constant.
Well, that's true, but you gotta appreciate the fact that I did not multiply every one of these components by 2. Only the first row.
Yeah. Well, you only modified one situation, that one equation. And
Perfect.
It's
Perfect. I think playing this game means all I really did is I multiplied the first equation by 2 on both sides. I can multiply any equation by anything I darn well please on both sides as long as it's non-zero real number.
Video.
My last
video?
elementary operation.
It's 1 minute into the second part.
I can replace any row with the sum of a multiple of another row. And itself. I can't do it. Is that legal? I asked, is that legal? What do you mean, yes, why? Somebody's making me why. Okay, I'm putting you to sleep, I'm sorry. I'll tell you why. All I did was I multiplied the first row by negative 3. I added the second row to it, and here's the sum. This is nothing more than the elimination method back at Math B, isn't it? It's how you and I solve systems, but technically speaking, if this represents one row in an augmented matrix, haven't I really replaced it? Here's this replacement. Haven't I really replaced it with the sum of itself and the multiple of another row? So I think when it comes to that third elementary operation, that's nothing more than a regurgitation of what you and I did back in grammar school or back in Math D. We solved systems using the elimination method. Nothing more. Do you guys agree? Okay, if you do, I'm going to start running with this. Let me give you my first example of solving a system of linear equations using this whole new technique I refer to as Gauss-Jordan elimination, which is putting the original augmented matrix in reduced row echelon form. Here I go. I shouldn't erase that first matrix. Here it is again. And here is indeed the game I'm going to play. It's a game of taking a walk, column by column. I'll start with the first column. And in that first column, you stop laughing. I'm going to look down. I'm going to identify the item in that first column that's along the main diagonal. And I'm going to force it to be a 1. And I will force everything else in that first column to be a 0. Now, to force the first entry in the first row, first column to be a 1, I'm simply going to take the first row. I'm going to multiply it by 1/2, use the result as my new first row. Oh, shoot. That's just using that second elementary operation, isn't it? And I think the corresponding equivalent augmented matrix has that second row completely unchanged. The first row, however, becomes, is that a 1, a 3/2, and is that 11/2? Oh shoot, you guys, I didn't do everything I said I was going to do in the first column. I need to make the second entry in the first column be 0. To do that, I will work on the most recently created leading one row, multiply that first row by something so that when I add it to the second row, the new second row has a 0 in that particular entry. I guess that means I better multiply the first row by -3 so that when I do add it to the second row, my new second row has a 0 at the very first entry. But in multiplying the first row by -3, I'm only doing it in my head. Officially, for now, it doesn't change. But in my mind, -3 times this plus this is as desired. If it weren't, I know I made a mistake in this decision process. -3 times this plus this is a -9/2 minus 8/2. Isn't that a -17/2? And I think -3 times this plus this is -33/2 minus 18/2. Is that -51/2? And I think I finished my task in the very first column. It's time to move to the very second column. And I'm going to play exactly the same game. I will identify the entry along the main diagonal in that second column, that'd be this item right here, and force it to be a 1. Every other entry in that column, force it to be a 0. Let's take care of the 1 business first. To force this entry to be 1, I will take my first row. I misspoke, didn't I? I'll take my second row. Multiply by, is that a -2/17? Use the result as my new second row. I think this is what I generate. Whoops. Sorry, I'm a mess. I think this is what I generate. Is that going to give me a result for which the first row, at least for now, doesn't change? Is it 11/2? But I think my second row becomes a 0, a 1, is that a, oh, how nice. Somebody must have made this example up out of thin air with nice numbers. And lastly, take care of my unfinished business in that second column. I'll force the entry in the second column, but in the first row, to be a 0 by messing with the most previous line for which I forced the leading one to exist. That'll be the second row. I'll multiply the second row by, how about -3/2? So that when I add it to my second row, the new, when I add it, to my first row, the new first row has a 0 in that particular entry. Let's give it a shot. I may be multiplying the second row by something, but it's only in my mind. I will not change it officially. But -3/2 times this plus this, oh, thank goodness it doesn't change. But -3/2 times this plus this is as desired 0. You guys, now I'll slow down with my arithmetic. -3/2 times this is -9/2. But -9/2 plus 11/2 is just 1. I think I've generated my solution. I think it's just simply the order pair. 1 comma 3. Did you understand the process?
What time is it? It's 8 minutes.
So if you do understand the process, well, let's check this out. Can I check it out? You guys, I'm really lagging behind. I should have posted this for you so you didn't have to write it down. If you guys don't mind, I am now going to go through the process of solving a 3x3. I was just hoping you wouldn't have to write it all down. So I typed it for you. I'll just post it online if you don't want to write this down. But you won't be able to see it, will you? Guys, I typed up an example. It's just that we're going to have multiple techniques of solving systems of equations. So I've actually solved it multiple different ways. But it's the same system, so we can see if we get the same answer.
Wait.
Yes, I'll wait.
So there's more than one way to solve a matrix besides Gauss.
Oh my goodness, absolutely. You can use the MAPD technique, which is elimination. Or Gauss-Jordan elimination on a matrix. Or you can use inverse matrices to solve the single matrix equation that I created a little earlier today. Or you can use a process on determinants called
Kramer's rule.
Kramer's rule. You guys be honest with me, because I come to class assuming this is a review. Have you seen all three of these techniques?
Yes.
Raise your hand if you've seen all three techniques. Wow, really? It's just standard curriculum for any pre-calculus course.
Kramer's rule?
It's college algebra.
Oh, yes. Well, college algebra, pre-calc, same thing.
Yeah.
Pre-calc just reviews a bit of trig. And if you haven't, don't worry about it. This is so light, it's a piece of cake for you because you're so mathematically mature, having reached this level. Because I don't think I'm applying any calculus here.
Huh.
It's just a slight, very light introduction to linear algebra, but don't think this is what linear algebra is this semester. We'll get more sophisticated. And I am not going to say this because I can never remember the name. Who wrote Alice in Wonderland?
Lewis Carroll.
Lewis Carroll. I had an honors student come to me and show me a technique that Lewis Carroll had, because he's as a mathematician. And Lewis Carroll had this wonderful way of reducing the amount of work it comes to dealing with Kramer's rule, whatever Kramer's rule is. Kramer's rule is extremely labor intensive. If you're a computer scientist, you can't stand it. Because the number of operations you apply increases significantly as the size of the system increases.
But
But what?
I mean, the thing I liked about Kramer's rule is there's a lot less room for error, is what I found. I found that inverse matrices, yeah, there's a lot of room for error on there, because you're generally adding a bunch of fractions.
You know,
and-
I grade these things all the time as
Yeah.
a math professor, and I find so many numerical errors with students using Kramer's rule.
Really?
Yes,
'Cause I had
really.
such an easy time with that in college algebra.
And if it's a 2x2 system, piece
Yeah.
of cake. Piece of cake. 3x3, not bad. 4x4, it gets
It's heavy.
cumbersome with arithmetic.
Okay.
So everybody, I do not remember example in series. I gotta bring it up. Now, if you guys don't mind, I am not going to discuss this first technique. It's not even discussed in the text we're using. It's just a mathy technique of elimination. Take in the system you see that I'm starting with. Take two of the equations and remove one of the variables. Take a combination of two other equations here and remove the same darn variable. To reduce it down to a 2x2 system for which now math really applies. I'll skip it. If you guys don't mind, I'm going to apply Gauss-Jordan elimination. But you guys, do you think, I typed this up for you, you're going to be posted. Can I just walk through it so you can see me go through the process? Even if you want to be lazy, put your feet up and not write, it's entirely up to you. So let me take the original system. I'll rewrite it as an augmented matrix. So you guys, so I have to look. Can you tell me what it is?
2
minus 2i.
Just give me the coefficients. Minus 2. Is it minus 2?
minus 2 minus 4 equals negative 6.
What's the next row?
2, 1, negative 1 equals negative 3.
And finally,
1, 1, 2, 5.
there's my augmented matrix corresponding, I should scroll up, guys, I'm sorry, to the original system of 3 equations, 3 unknowns. There it is. Now, to reduce this matrix, I've got choices. I can permute rows. But because of my first example, I'm nervous you've never seen this. I'm going to be more algorithmic, where what I do column by column is going to be the same. So I know I can interchange the first and second, or the first, I misspoke, the first and third rows to force that first entry to be 1. But again, let me be algorithmic today. This is a game of walking column by column. So planting my feet on the first column. I will force whatever entries in the first column along the main diagonal to be a 1. And I'll force everything else to be a 0. Let's take care of the one business first. I will take the first row, multiply by 1/2, use the result as my new first row. And I think my whole new first row becomes a 1, negative 1, negative 2, negative 3. Nothing else changes. Take care of everything else in blue along the first column. I guess I'll manipulate or operate on the most previous row for which I force a leading one to exist and combine it with the others. I guess that means I will take negative 2 times the first row, add it to the second, use the result as my new second row. I will simultaneously take negative 1 times the first row, add it to the third row, use the result as my new third row. And I think this is gonna be the corresponding equivalent augmented matrix. My first, yes, I'm sorry, yes.
Why do you choose to do the multiplication on the last row that you made, or that you forced to have a leading one?
Because it doesn't change the one. It keeps it there. And I accomplish my task in the first column to have 1 and then zeros everywhere else. It just maintains that placement of 1s and 0s. And don't take this the wrong way. You don't have to do this. I think you could easily force this entry to be a 0 by taking, well, the third row, multiplying it by -2. Add it to second, and if you did that, you'll come to the same solution in the end as I do. Along the way, your individual matrices will look different, but in the end, it'll give you the same solutions. And so I was trying to impress upon you before I started that maybe I'm not being the most efficient at solving the system this way. It's just I want to be very algorithmic for you guys in case you've never seen this technique being applied. And when I say algorithmic, I mean, look at the first column. 1s and 0s create. Jump to second column. 1s and 0s create. Third column, 1s and 0s create. In practice, you might find some shortcuts to alleviate some of the arithmetic. Particularly if you've got a lot of 0 entries in there. So you guys, let me commit to my action. This multiplication garbage is done here. I will not effectively change the first row, at least not for now. It'll change in a few moments though. But -2 times each entry in the first row added to the corresponding entry in the second row, I think gives me this is a new second row. Is that a 0? Is that a 3? Is that a 3? Is that a 3? As far as my third row is concerned, multiplying -1 to the first, adding to the third, I think that gives me a 0, a 2, is that a 4? Is that an 8? You guys can double check my arithmetic if you want. It is time to make a move. I will now scroll across to the next column and play the game again. I will identify in that second column which entry lies along the main diagonal, force it to be 1, and then force everything else to be a 0 in the second column. Let's give it a shot. Red business first. I'll force this entry to be 1 because by doing what? I'm hearing my voice too much. Multiply 1/3 to the second row, use the result of my new second row. I think that immediately gives me the equivalent augmented matrix. Is that a 1, -1, -2, -3? Is that a 0, 1, 1, 1? And then a 0, 2, 4, 8. Let's take care of all our other business in blue in the second column. Here, I'll take the second row. Add it to the first. That'll be my new first. Here, I'll take the second row. Multiply by this. Add it to the third row. And that'll be my new third row. Here too, I admit, I confess, officially the second row right now anyways doesn't change. However, multiplying the second row by just itself, or excuse me, just 1, and adding it to the first row, doesn't that give me 1, 0, -1, -2? But -2 times the second plus a third, I think gives me 0, 0. Is that a 2 and a 6? My last jump, that is to say my last column to work on, I will move over to the third column. Here's the entry in the third column along the main diagonal. And here's everything else in the third column. I'll force the entry box in red to be a 1, all the entries circled in blue to be 0s. Red business first. I'll multiply the third row by 1/2, use the result as my new third row. I think that's going to give me this. Is that going to give me a 0, 0, 1, 3? Oh, but shoot, nothing else changes yet. And lastly, if I'm not running out of room, everybody, I'll take care of blue business in the third column. I will now take the third row, add it to the first, use the result as my new first row. I'll take the third row, multiply by -1, add it to the second, use the result as my new second row. Let's play. Does that give me a 1, 0, 0, 1? Does that give me a 0, 1? Is that a 0, -2? And then lastly, a 0, 0, 1, 3. So what the heck does this really say? Well, it says my solution. is just simply for a triplet of entries 1,
-2.
thank you, -2, 3. There is my single solution. It just means if I replace x with 1, y with -2, z with 3, there's a point in 3 space, that's the intersection of the 3 planes. It also says that if I replace x, y, and z in any of these equations with those 3 constants, then the equations are true statements. They're all true simultaneously. So you guys, I solved the system. Can I do it again? Yes, Michael.
Damn it.
What was that? I don't get it.
That was crickets.
All right.
A little confused with the R2 plus R1 and then an arrow. What is that actually?
It's my gimmicky notation for column.
InstantRimshot.com.
So when I use something like this notation right here, I'm saying, well, take -2 times the first row. I misspoke, sorry, my fault. I meant to say, take -2 times the second row. Add that result to the third row and use the result as maybe third row. It's not what your author would do. Your author would write it this way. He'd say, add -2 times the second row to the third row. That's the notation he would use. You choose which notation you prefer. And if you prefer the author's notation, don't change it. I'm happy with it. I can read it comfortably. I personally like my arrows and my pluses better. If you don't like it, I understand.
Well, I mean, in regards to the actual matrix itself, what value does it affect?
Huge. Because what I think this one action right here does is it forces this entry right here to be a 0 without changing the first one. And it's what's allowing me to get these 1s down the main diagonal and 0s everywhere else, so that you can glance at my augmented matrix and just identify exactly what the solutions are reading along. Remember, my goal is to apply these elementary operations, take my nasty looking complex original augmented matrix, and force it to look something like this, that's a reduced per echelon form, so I can just rattle off what my solutions are. This says 1 times x plus no y's plus no z's equals 1. That's why the first entry is a 1. So I think those elementary operations allow me to reduce the matrix the way I did. What about this one? What example am I on? Is that number 2? Oh, you guys, I've got so much time. No rush at all. Can we do it again? Practice.
Mhm.
If I were to reduce this matrix in the first column, isn't a lot of work done?
Yeah.
Yeah.
All they have to do is force it to be a 0.
Yeah.
Can't they just, I don't know, take -1 times the first row, add it to the third, use the result as my new third row to accomplish the task of forcing that to be a 0? Doesn't that give you this? You guys, I'm cheating. I made this example up out of thin air where I've done more than half the work for you. Jumping into the second column, a lot of work done. Entry along the main diagonal is already 1. This entry in the second column is already a 0. There's only one more to make a 0. I'll force this to be a 0 by taking the second row.
Negative
Multiply by
second.
-1.
Add it to the third.
Add it to the third. Use the result as your new
Second, third.
Third row. Yeah.
And I think that gives me this equivalent augmented matrix. I want a yes or no answer. Is this a reduced per echelon form?
No.
See, I think it is.
Why not?
I think it
Because
is. I think it's in row echelon form, because all rows can come, there are nothing but 0s are at the bottom,
so we know that z is equal to
and
0.
each row has a leading 1. But any row that has a leading 1 has a leading 1 to the right of the leading row above it.
Yeah.
And I think it's completely reduced because any leading 1 is going to have 0s everywhere else in this column.
I noticed 2 things.
Yes.
The first one is that in the second step, your second matrix right there, you can obviously see that your second row is equivalent to your third, so you have redundant information.
I know, that's the way I created it out of thin air in my head. Yeah.
You did that on purpose.
Yes. Yeah.
And
So one row is equivalent to another row, but multiplied by scalar.
Yeah.
I would say that one row is a multiple of the other row, period.
There's another word for it. Something
Um,
about span.
They are dependent.
That's what linear independence versus linear dependence.
In that case, they would be dependent, yes, as a set of equations. I agree. You guys, if just the reduced rational form, I guess should be able to state my answers, but it's not like that one over there. It's not one's down the main diagonal. But it is a reduced rational form. I think I'm done. It's just that back in equation form. Not that I would write this. I wouldn't. I just write down the answer. But back in equation form, doesn't the first row say this? X plus 2y. Excuse me, I misspoke, didn't I? Sorry. X plus 2z, or x1 plus 2x3 is equal to 1, and y plus 3z is equal to 2. And if you guys allow me to let z be equal to t, then doesn't that necessarily imply, number 1, that x is equal to 1 minus 2t? And number 2, y is equal to 2 minus 3t. I have parameterized my solutions, and here are my solutions. There's infinitely many. Is a solution set consisting of ordered triplets? Where x could be thought of as 1 minus 2t, y could be thought of as 2 minus 3t, if z could be interpreted as t. And I'm going to range t over the entire set of reals. I think I've generated an infinite collection of solutions. For those of you who are Math 32 graduates, look at what I've just written. Z is this, y is this, x is this. That's a parametric representation of my line and 3 space. Or for those who are taking Math 32 right now, same thing. You've already got.
We just did it
Just did it.
today, actually.
You guys ready for another one?
On a test, would we have to identify within the near future whether our solution is a line or a planar?
Yeah, in the future, when I start talking about vector spaces and subspaces, I want you to identify that you really do have lines or planes passing through the origin in higher dimensional space. Definitely. For now, don't worry about it. Can I reduce it? Oh, hold it. No, don't look at this. Don't write it down yet. It's too easy. Sorry. What am I going to do to reduce it?
I would multiply the
One row
second.
to scale, multiply the other. Multiply the first row by -2, add it to the second. Use the result as your new second row. Don't you get this? I want a yes or no answer. Is this reduced completely?
Yeah.
Yeah.
I think it is. And I think what it says back in equation form is that x minus y plus 2z is merely equal to 1. And if you allow, you're right, that's an equation of a plane immediately. But if you allow z to be, and let, let's have another one, y be, so that x is going to be 1 plus s minus 2t, I can express x in terms of those two other parameters. And so I think my solutions going to consist of a set of ordered triplets, x, y, and z. It's just that z is interpreted as t, y is interpreted as s, and by the way,
So
x is going to be
how did you
plus
let
s.
t equal t?
That's a Z.
That's a z, and that's a t. Are you happy?
Yes. I am now.
Good, I'm glad, Chris.
Is it
How is
really
that a
the most
Z?
meaningful way to
What?
express solutions in order triplet that way? Linear is more than just write the equation in plain? Perhaps.
Yeah, can I show you why? I'm not sure going to find this chapter. I think it's so much nicer. By the way, can I finish my sentence first? I meant to say where S and T goes range of variables. So you guys, Chris is saying this. Why can't I just leave my answer like this? Clearly to the reader, that's a plain. Well, if you've taken Math 32. I maintain it's so much nicer for this reason. I'm running out of room. Can I come back? Sure. And here's my solution set. this is too important, I wanna talk about this. 1 plus S minus 2t as t as S and T does its business. I think it's the same as this set. Which is the same as this set. And you can clearly see how, at least with the second two terms, that's a linear combination of these two basic elements, 1, 1, 0, and negative 2, 0, 1. And I can talk about, Chris, linear combinations of basic elements that generate all my space. Now, this is a bad example. You don't know this. But whatever vector space is, this is not one. It's not one because I've got that lingering one term out here that has no coefficient as a parameter. So technically speaking, when we do study vector spaces, this will not be a vector space because it's one entry. But if that were there, that is slick. Now I can talk about a set generating my entire vector space, which is simply a set of those two basic elements without the S and T's. I can talk about a spanning set for everything in that space.
So we should write our solutions in the first set form, right there, because it is most convenient to work with when we start talking about it.
Yes, so today, as of today, I want you to write in this form. It's just in the near future, you're going to be writing it actually even different than this. We'll split it up even.
So I'm just a little confused as why you renamed Z and why you renamed Y and why you just didn't work with those variables in there.
You know what, you've got a good point.
Yeah.
You know, I could have just as easily said, call the thing a Z, call that a Y, and this is 1 plus Y minus 2Z. I
Yeah.
could have done that. I have a tendency to like to use T's a lot when I can because oftentimes what happens is I'm tracing out a curve in 3 space over
Okay.
time T.
Okay.
It's a common application. And besides that, I want to think of these things as ranging over the reals. I want to be parameters. And when I look at x's and y's and z's, I think so coldly about the x-axis, the y-axis, and z-axis. Whereas I don't necessarily have to think about it that way when I write it in this form.
Okay.
And I can talk about linear combinations where those coefficients out front are not necessarily z and y values.
Okay, so I understand the time, but what about the S? Does that
It's just a
signify
previous
anything?
letter in the alphabet.
It's just a
so
previous
it's
letter.
related
Okay.
to it, or close to it, I should say.
Okay.
It's a tendency we tend to have.
Okay.
Wow, you guys. Let's see how much I said when I come back into the book and look at the exercise set. You guys, I'm talking a lot because shoot, these chapters are so easy, right?
Yeah. So far, at least.
So far, at least. So, to augment last night's homework that went through 2.2, in 2.3, jeepers, I want you to consider not much, just 1 through 17 odd. There's just not a lot in there. Oh, sorry, I'm not done. 2.4. One through 11 on. 15. 23. Sorry, you guys. I'm still not done. So 2.5. You're such good sports.
And so we're only going to be quizzed tomorrow on homework from last night?
Yeah.
Okay.
And 2.5. 1.3. 9.13.
9 through 13?
No, 9 comma 13.
1 comma 3?
1, 3.
1, 3. Didn't say 9 and 13. And then 17.
So like 1.3 or something like that? It's a...
Number one, number
One.
three, number nine.
Okay,
Number
okay,
one,
okay.
Number
Okay.
3, number
Okay.
9, and number 9 is a bad Beatles song. Number 13, number 17.
Yep.
Ooh, number 19.
13, 17,
33, 35. I'll just stop there. If they're difficult, just do more. And you guys, when I go home tonight and write a quiz for tomorrow, it's only going to be over the first 2 sections of chapter 2, not over the homework I just assigned, obviously. Chris?
Tomorrow's last week of honors conference.
Yeah, those of you who want to do honors, you need to speak to me sometime tomorrow. What's the deadline? Do you remember? I think it's 3 o'clock.
So what about for Math 32?
I know. You better find me tomorrow morning.
Tomorrow morning for Math 32?
Yeah.
Okay, so,
I still haven't created contracts. I won't do it until today or tonight.
well, I'll be here tomorrow, but
Make sure
you
you
told
nail.
all, you told all them in the class that you had talked to them about it at the last minute.
I know, but you didn't remind me, so I forgot. I need reminders.
Okay,
Brad, when I came in today,
Yeah.
let's just say I needed the